Thanks a lot. Can you guys hear me? Yeah? Good. So, indeed, today we're going to tell you a story about a web platform that solves a lot of problems for us at Spilgames. And as any solution or any story or any platform that anybody ever presents to you, this is not a universal solution. This doesn't work for every case. Nothing does. But this worked very well for us, actually. And the problem that was trying to solve is a growth problem. The point where actually, some call it luxury problem. So when you actually grow way farther than you had expected to be growing, and suddenly you have a big bowl of spaghetti that's delivering functionality 24/7 to a huge amount of users, and you're afraid to even look at it, and you need to touch it. So this is kind of what we solve with this thing. So first of all, let me introduce myself. I'm Enrique. I work as a software architect for Spilgames. I'm a very passionate Erlang developer. Is there any Erlang developers in the room at all? Okay, well, that's not a zero. That's actually good. So, yeah, I'm enthusiastic about testing, but overall I love beautiful code, clean code, code that I can read and understand in any language. I mean, I think that should be a must in any product. But anyway, that's me.
Hi everyone, I'm Cara. I have been working at Spilgames for 2 years now. I'm a front-end developer, and I love designing and crafting large implementations that are scalable. So, and I'm a SaaS enthusiast. So,
all right. So about the company, Spilgames is not a really known name. But we're a big gaming platform, actually, one of the biggest out there. So according to the latest market studios, it's Electronic Arts before, but still, you know, it's a big league. We serve data to more than 190 countries all over the world. I mean, when we see the data, we get like 120 gigs of data to our data warehouse system every day. And we see data coming from countries that's like, wow, do they even have an internet connection there? You know, it's come on, it's just surprising. And we have more than 180 million unique users a month. And that's actually the challenge. So we do serve games. We are a gaming platform. We do not develop nothing close to all the games that we serve. We do have a game studio, but we do kind of 10% of the games that we serve. Right? The rest is just licensed games or games that can provide it to us. The challenge here is the traffic. The challenge here is that we have a lot of portals, like 47 portals all over the world. And all of them should serve games in a very nice way. So
I just want to give you an understanding of our product and the challenges we faced. Basically, we serve games all over the world. And in order for us to be able to serve relevant content to specific end users, let's say a specific target audience, like females. For example, we have 5 brands or channels, if you want to refer to it as that, which we serve our audiences with. And within each of these brands, we have up to 15 sites that we actually are able to serve localized content to specific regions across the globe. And each of these sites, it's part of our strategy to ensure that they have a top-level domain. And there's a couple of examples here. agame.com is for teens, so the brand teens in America. And games.co.uk is for families in the UK. And Juegos de Chicas is the girls' brand for Spain. And if you take a look at this slide, you'll see an example. This is our family brand. And it's the American site, gamesgames.com.
So now you have an idea of what we do. Let's show how the old portals look like inside. So this is kind of what it was. It was a 3-layer architecture. So on first side, you have on top, you have the portals. The portals are big code bases, independent. They provide, mostly they were PHP or some Python over there. An application layer below, which is the one that accesses the storage layer, basically. So the portals serve all the front-end code, and everything works based on AJAX call. There's nothing mind-blowing. You have seen this thousands of times. The only particularity, if you want, is that the access to the data is controlled by that application layer. which is the only one allowed to connect to the databases, and is the layer that is implementing the business logic. So if you think about it in an MVC model kind of thing, the portals here are implementing the view and the controller, and the model and the data access is abstracted in the application layer and the storage layer. Yeah. So this thing had pretty good things, actually. The first one, well, the overall thing is that it allowed us to grow to the point where we are now. So allowed us to have massive amount of traffic and, of course, make money out of it. So it performed acceptably. It performed good enough to get us there. Let's say that. It provided clear layer separation, so it was easy to know where you had to touch to modify something, at least on the business logic part. And again, it allows it to grow very fast.
Okay, per brand and site development, each of our brands in the old architecture had an individual code base. They weren't actually, they were similar, but not the same. So they had a lot of slight differences. And it made developing per brand really easy. You just get into that particular code base, make the changes that you want, and within that you could also target specific sites within that particular brand very easily if you wanted to implement a feature. And because it was written in majority PHP, Ajax, JavaScript, it was easy learning curve for new developers because most developers are competent in those languages. So overall, it was acceptable.
So it looked pretty good, but really it wasn't really good. So the problems were, yes, it performed acceptably, but because we had lots of front-end caching, a lot, which is a tricky thing because when you deploy a bug fix or something in a call that retrieves tons of games from your backend or something, then you do have a very big issue, which is the cache is called. The call is cached. So your bug fix might get to actual real users sometime. 3 hours, 4 hours is really bad. So yeah, you can also invalidate the caches. We all know that. But when you have lots of levels of caching in different parts in the code, you really do not know what information is living in which one, and some of them are absolutely required because if you remove them, you will kill your backend. Then it's not easy to clean the caches. So that was a bad point. Another bad point is it was not easy for us to have global features. Something Kara introduced you to the concept of brand for target audiences. It's very nice that if you implement something like a list of recommended games for something based on your activity, you can share that in all the brands rapidly. That was not the case because each one of the portals had a slightly different implementation per brand. So you could share most of your code, but making it work, well, required specific debugging, and it was not really plug and play, which was bad. And there was a lot of logic on the client side. Because of this need of cache a lot, you need to know when to cache, when not, depending on the call, stuff like that. So we had this application layer with the business logic to retrieve the data, beautifully grouped and this kind of things, but still, we needed a lot of logic in the front end as well, which was actually slowing us down.
Long time to global market ties into what Enrique was saying, because the fact that the code bases were different and we had to implement features. If one of the business guys from one of the brand's teams says, oh, this is a great feature, let's implement it here, and then somebody from the family brand says, hey, that's really cool, we want it on our brand, then it takes number of days to actually port that implementation to another code base. So it meant a really long time to the global brand market, basically. And we had redundant code because our features weren't really documented well, and it was just, as he said, it was just spaghetti code. So if you wanted to either add a new feature, you wouldn't even know if there was something similar that you could just reuse. And if you wanted to deprecate a feature, you had no idea if you were actually reaching the entire scope of the code to remove it because it was just such a mess. So it was a lot of redundant and duplicate code. And tiny changes, for example, to important functionality, let's say, for example, the login functionality, you weren't sure whether the change that you were making was going to break something. You kind of were sure, but not 100% sure. So you would have to have hours of regression tests just to make sure that something that took you a half an hour to do didn't break important functionality on the site.
So at this point, we decided to come up with a wish list. And it's like, all right, so if we could start this again, keep the audience, keep the traffic, keep making the money, but if we could really replace the product in full because it's unmaintainable, what would we like to have? So we started thinking about it, and well, some of the points are kind of obvious. So we want to have isolated requests. So what happens to a user only affects that user. Well, that you have kind of everywhere. We wanted to have isolated features. That was not that common, meaning a feature is just some part of your web page, and that feature can crash and will not affect the rest of the page. All right, so that's something that's really good. When you deliver different parts, our websites are composed by different tiny parts that provide, I don't know, user area, user information area, recommended games, popular games, most recent stuff. So if one of those breaks, there is no reason for you to not show the rest of the page to the user, basically. So isolated crashes. Feature toggling on runtime, same concept. You should be able to enable, disable something is behaving correctly or not without affecting the whole page experience. And linear scalability with supermarket hardware. So more traffic, plug another server, that should do. So for these concepts and soft real-time response and stuff like that, yeah, it was kind of clear from my background what kind of technology actually applies to get this thing if you can choose to do it, or most of it, server side. And that was Erlang. So this is not an Erlang talk. We're presenting just the platform here, but if anybody's interested about having a chat about Erlang, just please approach me anytime. So developers had wishes as well.
Yes, we did. So one modular code base was key here because of the fact that we needed to have that feature to global market in the quickest possible time. We needed the ability to say, okay, implement this feature once and just port it to all the brands. And once it was created, it would be in the library. So whether you use it or not is irrelevant. It was available. And explicit component specifications was very important because we wanted the ability to take a component and say, okay, these are your requirements, and if this isn't specified, it's not allowed. The platform will basically say, sorry, uncontrolled behavior, stop. So that was an important thing. You could specify if it had dependencies, CSS, JavaScript, that sort of thing, if it was omitting events, etc. And that would stop unpredictable behavior, basically. Small features that were easy to deploy and roll back. This ties into the component thing, basically. So you have a feature that's isolated. You can deploy it independently of any other code, roll it back if you need to, and it wouldn't affect any other features on the page. And coupling of front-end technologies, I'm sure if there's front-end developers here, they'll know the nightmare it becomes in a framework after many years of developing. Basically JavaScript, CSS, HTML become so interdependent on one another that you remove a class thinking it's only applying for style, and the next thing you know, you've actually broken functionality because the JavaScript is actually using that class, and it can become a big mess.
So before jumping into building something, we decided to do a quick market study of what was out there. And well, in Erlang there are a couple of very nice web frameworks, Chicago Boss and Sotonic. They all provide a nice layer separation and scale very nicely, easy to learn, nice documentation. So there was actually some cool stuff. The problem is that none of them actually considered feature isolation as one of the key stones in their design. And for us, that was actually the thing that solved our problem, right? So, well, if we need to implement that and put it into the guts of a beast already, probably not the best choice. And the second one is kind of obvious. So I touched on this before. We had a 3-layer architecture where we had a model we were happy about and a database layer we were happy about. We just need a different way to use that. That's better and that scales and that provides the isolation bit. So none of these frameworks are actually easy to decouple the controller part or the view controller part from what's the model in them. So we decided to just pick some parts of them and drop the vast majority of the rest. And of course, this study was done also for the front-end technologies.
So we basically took the same approach. Again, front-end developers, like there's hundreds of frameworks available. We didn't take a look at every single one of them, but we looked at a lot of them, and they had great stuff. You know, responsive is important now with all the devices that are available, and it was an important part of what we were doing, and so they offered responsive grids. They had cross-browser compatibility right out of the box, and the use of a CSS preprocessor, which was important to us because we'd actually started using a CSS preprocessor in our old architecture, and the developers found it really easy to use, and it made development a lot more flexible, and code was more maintainable. So this was important for us moving forward. But once we took a closer look, we realized at actually what we wanted. We realized that these had a few flaws, and the first one was the design was too tightly coupled to the structure. For us, in order to actually take one component and allow it to be ported to all the different brands, we needed to have a separation within the CSS of, okay, the wireframe structure, if you want to call it that, and the skinning or the theming. They needed to be completely separate. They couldn't be tied in one module. And the second thing was a lot of the grids use classes that you put into the HTML. So you would throw in like a bunch of classes and you'd get the behavior that you wanted. And that was a problem for us because we needed to keep our HTML as semantic as possible, because on the one brand you might need a bunch of classes, but on the other brand you don't. So you needed to keep that stuff out of the HTML. And these were the two things that led us to say, okay, do we want to take the time to take one of these frameworks, rip the guts out of it, and modify it to what we need, or shall we just build our own? And we decided that we'd rather build our own.
Yes, so now we're into the interesting part of the talk. So what we came up with. Well, this is how, well, I don't know if this is really visible. I'll show it better. But basically the idea is, this is one of our portals, spell.se, which is for teens in Sweden. And what we did with these pink boxes was actually break it in pieces. So each one of those pieces should be an independent piece of functionality, right? So for example, over there, and again, I'll show it cleaner, there is a top 10 list of start games, best rated, most popular stuff. So based on your behavior, this is what we normally deliver to you, what you think is suitable for you. So let me show you in a real browser how that looks like. All right, so this is the same portal, just running from my local machine. You can check the .loc in the URL box. That's about it. So what I'm going to do is pick this feature box in here, introduce a bug on the code of that thing, recompile the code, and then reload the page, and you'll see what happens. This is probably not very readable. Better? Yeah? No?
Can everybody see? Well, of course you can see, but can you see what he's doing?
Okay, so I'm commenting this line over here. This, well, very short explanation. This in Erlang will never work. I'm trying to match something that's a fixed constant with something that is a fixed constant and is different, so it's going to explode, right? So now you can see the portal again. If I just refresh the page, I get exactly the same page, just with a hole on it. And that's the basic idea. So that part of the page couldn't work. It failed. It crashed badly on execution time. And then I still deliver you all the rest of the parts, basically. So it's nothing really mind-blowing, but it's a very, very interesting concept for scaling the development, because stuff works nicely. And another very interesting point is that you actually can see, for development purposes, you can play with this in isolation. So this is actually one widget that is meant to show you a list of popular games. You can render it alone and debug it alone, debug the styling, the stuff, the amount of games that you want to put in there, pass options. You can do the same with the widget that I just showed you. Or it can crash in this case, and then you will see the error page. Yeah? So, back to the presentation. All right, so how does this thing work? The idea is that most of the magic happens server-side. And all the page gets generated server-side. We deliver content that, based on what our data warehouse tell us, is the most suitable for you, depending on your device, depending on your preferences, the stuff that you have played before, whether you're a registered user, whatever. So we enter with a path, let's say /action, in one of the portals, right? And that path is mapped to a widget name. And that widget name will be the entry point of a whole tree of widgets that are the representation of your page. When I say tree here, I mean a tree data structure. That's what it is. Yeah? So server side, the tree is created and is rendered. And render here means that we use templating mechanism for the HTML. It's called early DTL. Are you familiar with Django for Python? Anyone? Yeah? Okay. So it's a clone of Django for Erlang, basically. That's what it is. So basic HTML templating, we render the result of the page after trying to execute all those widgets. We remove from the page that was generated all the failing parts, yeah? And then we have a full working HTML page. And then we serve it to the client. Of course, in that page, there will be some other stuff that's not plain HTML, like CSS requests and CSS classes, JavaScript modules, stuff like that gets added, gets requested, all is part of the templating. But the idea is that the page that we serve server-side is already complete and usable, just with the HTML. Yeah? And then once you serve it to the client, you can do some optimizations in JavaScript. And the really cool part of this is that you can actually guarantee that you are generating a unique page for a user with all the data you know about that guy, right thought for that guy in a guaranteed amount of time. So saying, I'm going to deliver within 1 second a page, the best page I can based on all I know about you. And it's going to leave my server in 1 second. And since I'm doing just optimizations on the JavaScript side to make it look better, to make it more usable, to facilitate your experience, even if that takes long or something like that, well, it's not an issue because you have a working page. You have something that you can use, right? This is a really, really, really cool thing. You know, if I serve within a second, if the page takes longer to get to you, it's because you have a very poor bandwidth, basically. And, well, I can try to mitigate that, but there's not really a lot I can do about it. I mean, if you're on a crappy connection, you're on a crappy connection. That's it, right? So in this case, I serve you a page. Now, of course, I also learned that if you're on a crappy connection, consistently, I'll try to serve you a lighter page. But that's the whole idea. And this is how one of those trees would look like. So each one of those boxes are actual widgets. You have already seen their isolated components, and Kara touched upon a bit. They are fully specified components. For each one of them offers a set of public properties that can be modified, either via the query string or via the parent widget in the tree. For example, the popular games widget that I showed offers in the interface options like amount of rows and amount of columns that you want, so that it looks different, basically, just passing options. Or if the parent sets a different set of options, you could say that for family portals, we use 2 rows with 4 columns, and for our girls concept, whatever thing that you can come up with. Right? Another thing is private properties. Private cannot be modified. They cannot be modified. Why the hell are they there? They are there because if you do not declare them, you cannot use them for flow control in your HTML templating. So you cannot put a variable in your Django template that you are not declaring here, because it will not work. It will just refuse to compile. This forces you to create a specification of your component that is always up to date with the code. Otherwise, the code will never work. So this is about enforcing the documentation to be right. In this case, documentation being a minimal specification of your code. And of course, the last box is the decoration needs. And Kara will touch upon that. So,
Okay, so I just want to give you an idea of what it's like now as a developer to work within this new architecture as opposed to what I described earlier, which was more of a brand focus. Basically, before, if you wanted a feature, it was because you were saying, okay, within the family portal, I think that we want this really cool feature, so please build it. Whereas now, you have a feature-focused development. You can say, all right, let's build this really cool feature and put it on all of our sites because it's possible. I just have an example here, which is the hot box or featured games box. And it allows us to build it here, and this ties into the dual layer in the CSS as well, because the first time you build it, it will have only structural styles. So everything that is common throughout all the brands is in that first module layer within the CSS. So you build it, the functionality is added, and you have a widget that can be ported to all the brands. And then in your second layer, you can add the styling for the particular brand that you're on. Here, this is the family brand, this is our girls brand, and this is our teens brand. So it's one widget to serve all brands. And it's minimal to no impact on other features because you can specify your requirements, or with CSS, you can code specifically for that particular widget, or you can do global. And here I have used the featured games example again, and there's a snippet here. And this snippet is basically what Enrique was talking about earlier, the flat file, the app.src file, where we specify everything for that particular widget. And this gives us a lot of control because we can change functionality, well, we can specify stuff that needs to be different for a particular brand or a particular site. And what I've got here is I'm stating for the family brand, the number of games shown should be 3, but for the 88, which is gamesgames.com, the American portal, I would actually like there to be 5 games, and the reason for that might be because we've determined that in America, if there's 5 games in that featured box, we actually get more gameplays. So it gives us a lot of control and a lot of flexibility as well. Okay. So now, let's take a look at how we actually build the CSS. Again, keeping with the theme of the featured games box. On the left, we have the image that you saw in the previous slide. And you can see how we actually separate the structural styles from the theming or the brand styles. And we specify, this is where Sass comes in, where it's really great, because you can specify variables for your properties, values, and what you can do then is you have a configuration of all those values per brand in a single file. So for each of this will be for all brands, and this may be for 2 or 3 of the brands, but you can have separate designs. And here you can also specify with Sass the values. And then what we do is, per brand, we have that Sass config file where we assign the values there. And what you can do if you have that file is you just open the file, change the configuration, and a particular feature will globally change. So you don't have to, we're in the old code base, if you had a featured box on 3 locations, you would have to go and change it in 3 places in the code. Now, you change it in 1 configuration file, and it changes across the board. So it's a lot less development, it's a lot more maintainable, it's flexible, scalable, it's a developer's dream, basically. And then obviously keeping our HTML is now very semantic. As I mentioned before, it was really bad, and now keeping it simple and semantic means that we can use it across all the brands. And then this is something that a lot of companies have started implementing. It's a style guide for the styles that are available for a particular brand, and we've built this for each brand, once we had the components and we determined where a component is for all the brands, we assign styles and we put them in this style guide. Before it was ridiculous. You can see a number of buttons here. Before we had like 22 versions of one button. It was ridiculous. Everyone was individually styled within a style sheet, and it was unbelievable. So now we have a definition for every style that we need. The developers come here, okay, this is what I need, copy, paste, and it works perfectly right out of the box.
Yeah, so, and by the way, that actually fits very well the document by example principle. So it's really, really good stuff. Anyway, there's a lot of complexity that we have shown, indeed. The widgets themselves are isolated, they're small things, they are independent, they form the website, stuff like that, but they have configuration and they have to declare what they do, and yeah, they also have different defaults, and the point is, with the configuration tweaks, but you are still serving the same code to lots of different portals, so stuff can still go wrong. You should be able to fix it quickly, stuff like that. So we created a manager application to avoid ourselves looking a little bit like that body over there. So what we use is central storage. In this case, is Swift from OpenStack. Don't know if anyone has worked with that, but it's a really cool distributed binary storage. With a very simple JSON API, you can use it from anywhere. It just scales itself, super cool stuff. So we use it as like a central repository of our components or widgets, right? Then, let me pick this. So then this guy over here will talk to Swift to show you as a person using just an HTTP interface what's available. So this is the catalog of widgets that we have for you in all these versions, right? And then of course the manager component connects to all the different platforms. I mentioned scalability and Erlang. This means for a brand, for example, we have many machines here. This is one machine, another machine, another machine, another one, another one, another one, all of them, and there's a load balancer that is actually addressing the traffic to them. Yeah? And this layer you can scale as much as you can, as much as you want, basically. The point is this component here is able to talk to each one of these different machines that are actually being hit by the users and pick something from the catalog and apply it in all of them. At the same time, just with one click, with a graphical interface, you deploy to all your cluster. It takes 1 second. It's really good. And who says deploy says roll back as well. Yeah. Yeah, so far that you could achieve more or less easily, or yeah, with a lot of complication. But there is something else. So what happens if this guy over here dies? Yeah, this guy, only this, why? The first one just dies because, I don't know, the memory module of the server just went off, right? And you need to replace it. And it's going to take you 1 day to find a replacement for it. Luckily, you can survive with the other 2 ones. So you turn it down, this link from the load balancer, customers are hitting this too, customers are happy, you're happy as well, and go to the shop and buy a new memory module. So far, so good. In the meantime, development, of course, doesn't stop, and somebody actually picks a new widget or set of widgets from here, different versions, and applies it to the connected platforms, which are only these 2, right? So customers are coming and are hitting this, see all the changes, this is really good, and the next day, your operations guy comes back from the supermarket and plugs in the new memory module here, the machine comes up. And then you have customers that are load balanced to this machine that are seeing one version of your page, and in any of the other 2, they're seeing a different version of your page. And if you have to maintain that manually, that's hell, because this is not always one machine for 1 day. This can be a set of machines for a random amount of time. It's really bad. And maybe it was not 1 day, but a week, and then you have to trace all the changes that happen in development during a week to make sure that you... This is horrible. It's not doable, seriously not doable. But this application is smart enough to do it itself, and that's one of the beautiful things that you can do with Erlang. So this is connected. When this guy comes up, this guy will discover it and will check, hey, there's a new machine trying to join an existing cluster that is being hit by customers. So let's pick the whole configuration that one of these machines has, retrieve it from the central repository, and force it here. And only when this node has the exact same configuration than the others, then can join the cluster. And the machine does it for you. You just have to look at it, and at some point it has a green light, you re-enable it on the load balancer, that's it. Super simple. And Kara will show you actually how simple it is.
So I just want to show you our widget manager. Basically, this is the manager that we manage all the full library of widgets. I'm going to do a quick demo. Okay. First of all, okay, here you can select the environment that you want. So because we have the different brands, you can select whether it's the girls brand or the teens brand or the family brand, and then it'll bring it up. And here it lists all the widgets that are available, and it shows the version running of that particular widget. So if it's yellow, it means that it's not running the latest version, and if it's red, it's obviously not on, it's off. So I just want to show you an example of how easy it is to roll back or deploy something. If you take a look at the logo here, it's obviously got a Halloween theme. Maybe it shouldn't anymore, considering the fact that we're now in November. So we go to the manager and we select the widget, which is the header logo, change the version. And that's how simple it is. So another great thing about the manager is that it has logs. I've lost my mouse. These logs basically show all activity within the manager, within a particular environment. So you can see, let's say, for example, we're watching the monitoring of the widgets and something spikes. Okay, we go, what the hell just happened? Let's please check the logs because somebody's deployed something that was obviously got a bug in it. So you go to the manager, pull up the logs, and you can see, okay, Enrique changed something. Please tell him to roll it back and fix his bug. So that's really cool. Are we back? Yes.
All right. So what's next? What's in the future? And with this, we'll wrap it up. So we have learned some stuff about documenting by example. We have already touched upon it. Being friendly with the developers, just show them how to do stuff, listen to them. They will provide you very good feedback. When you build a big platform like this that's going to be used by all the developers in your company, you should actually take care of their needs, listen to them, they know better. And reinforce the concept adoption, review the code many times, especially when you think actually the person or the people working that code already knows what they're doing, then review much more, because they might actually be going away from your original idea because they're having a better one. So please keep the eye. And measure performance from the earlier stage. So as early as possible, start measuring performance. It's easier to fix it at the beginning. Coming up, we have native widget to bucket connectivity. This means that at the moment, the widget layer is talking to the application layer with the business logic and stuff like that via HTTP. This has an insane amount of overhead that's not needed because both layers are Erlang, so they can talk Erlang to each other, which is way faster. Measure performance on continuous integration server, and having a historical image diff for widgets. So you can say, well, in Internet Explorer, this widget, Internet Explorer 7, this widget has grown these versions during this amount of time, and at some point, you know, look, that corner in there started looking funny, and it was in version 1.2.3 by developer X, so please go fix. And incorporating more device browser capabilities, making them available for widgets before the widgets render the template with the HTML, so you can actually generate a better page for the device. We have used different kind of libraries, software, mainly SAS, early DTL, part of the Django clone, Cowboy as an Erlang web server. If you're into web development in general, you should give a shot to Cowboy. It's really easy to start, and it performs so crazy well. So that was about it. If you have any questions now, please shoot.